We're going to step away from all the operations, all the algebra that we're doing with functions, adding them, subtracting them, multiplying, dividing them, and things like that. And we're going to go back and we're going to review some important concepts about systems. So 7.5, the I can statement is I can solve systems with linear and exponential functions. So let's write linear right here. Linear and exponential functions. Now, a reminder before we get going on this, a calculator is a really awesome tool, but you still have to provide the brain power. You've got to provide the brain power to work it correctly, because if you put the wrong thing in, you are going to get the wrong thing out. No doubt about it, okay? Now, if you need a refresher on how to solve systems by graphing on a calculator and find those intersection points using second trace, the calculate menu and stuff like that, please take a look on the back. And you also may want to reset your calculator, reset that memory using those steps that we've talked about before so that you get the right answer and somebody hasn't messed with your calculator. Now, what does it mean for a point to be a solution of the system of equations? Well, a reminder here, if we've got a solution to an equation, it makes the equations true. And that's true whether or not we're trying to get one solution to be solved, or one equation to be solved or two equations to be solved. If we've got a system of equations, we want all of those equations to be true. Now, the most basic way to solve a system is by graphing. Most basic way to solve a system is by graphing. Now, graphing can be really tedious, but a calculator does make things easy. Unless we've got a really good idea of what the function looks like, where it is, how big it is, and what the function values are, a good place to start is by graphing things in the standard window. So we're going to graph things in the standard window to start with. And a reminder there, we just hit the zoom button and hit 6. Now, if we don't see anything, we should hit the trace button. So I'm going to write trace right here, because if you hit the trace button, what it will do is it will show you the x value and it will show you the y value. So it will show you a coordinate on the graph, and if it's maybe way too big, maybe way above the window or way below the window, then we can get a sense of what we might need to do in order to change that. So if a graph is given with a scale, one thing that we can do is we can match the scale, match the axes using the window settings. So we're going to use the window button and we'll adjust the window settings. And if we match those things, it's going to make it a lot easier to draw the graph and sketch things out and find their intersection points. Now, please don't forget this. X and Y intercepts, where the graph crosses the x-axis and the y-axis, those are really important. If we get the x and y intercepts correct and we get the intersection point where the two graphs cross, then we've got a pretty good sketch and we've probably got most of the important features on the graph. So let's go ahead and come down here and let's take a look at some of these functions that we're asked to find the intersection for. And we are going to use a calculator for these because that's going to be the most accurate way to get a good approximation here. So you'll notice that this one is already scaled, and we've got this in a format where we can put this into the calculator. So I'm going to go ahead and bring up the calculator, make this window a little bit smaller, and then we're going to go to y equals and we're going to start putting this in. So I'm just going to put in negative x divided by 2. And then I'm going to put plus 1/4, and I'm just going to do 1 divided by 4. What that's going to do on the calculator is it's automatically going to tell it that, hey, decimals are okay on this one. And then we're going to hop down here. Oh, I need to put that as a plus. Oh, good catch there. Glad I saw that. Okay, so we've got a negative x over 2 and then plus 1/4. That's why I always like hopping down on the next line and kind of double checking and looking back and forth. Then we've got 4 raised to the x. So we hit the caret key right there. We'll hop down here and hit minus 10. Don't hit the negative there. And then I'm going to hop down. Now, once I hop down to the next one, again, it kind of puts those right next to each other. I can kind of double check and make sure that I've got them put in there correctly, and I'm in good shape there. I'm going to go ahead and do something that I didn't advise to begin with. I'm going to hit zoom, and I'm going to hit 6. That's going to graph this in the standard window. Now that's not too bad. We can actually see where they cross here. But the scaling on this one goes from negative 20 to positive 20. So let's go ahead and take a look here. I'm going to go to the window. Now the x min is negative 10 and it goes to positive 10. We're fine with that, and a tick mark every one. We're going to come down here. The y min is negative 20. So let's go ahead and put in a negative 20. And the maximum is 20. So if we want this to look just like we have over here, we're going to need to make our calculator look like that. And it does look like, yeah, this is putting a tick mark every one also, so we don't need to change the y scale. Now we're going to go ahead and hit graph. And this is what it looks like. Okay, so that actually looks a little bit more messy, but we can kind of tell what goes on here. I'm going to go ahead and hit graph, and you'll notice, whoops, hit graph again and trace. You'll notice that we've got these ugly function values right here. Now remember, this one crosses at 1/4, so that would be really tough to see over here. So I'm going to come over here and I'm going to put a dot about right there. Okay. And then I'm going to grab another one. I'm going to come out here and I'm going to hit, let's say, where are we at -10? So I'm just going to type in -10 and hit enter. Well, we're at 5 1/4. So 5 1/4 would be about right there. Okay. So I'd need to connect the two of those. And then I'm going to hop over on the other side and I'm going to go to like 8. So let's see what happens when we're at 8. We're at -3.75. So at 8, this is 10, this would be 8. So we are about -3.75, so about right there. So the graph is going to look something like this for that line, and I'll put an arrow on each end. And then I'm going to change colors, and let's do the exponential one there. So I'm going to hit the down arrow. That's going to put me on this one right here, and look how big this is. This is at 73,000. 8 and 70, yeah, 73,000. So I'm going to immediately hit 0. That's going to center it right down here. So it crosses at -9. Okay, so I'm going to put a dot right there. And then I'm going to go over a little bit. Okay, now that's going to go up very, very quickly. I'm going to find out where it is at 2. So we'll go ahead and hit enter. At 2, it's at 6. So that would be about right here. Okay, and then if we come over here, now I want you to notice what happens. This is the first time we've done this on a calculator here. I want you to notice what happens the further we go out. Look at these y values. Whoops. Hit trace again there. Hop on that one. As we go further and further out, okay, it just stays, it gets really, really close to -9.99999. In fact, the further we go out, the closer it gets to -10. So here's what's happening here. We've got an asymptote out here. It's going to get closer and closer and closer to this horizontal line. It's just going to run along there, hit this, and then it's going to go up like that. Now, that's a decent sketch. You could probably do better than I do, but what we're really interested in on this is we're interested in the intersection point. So I'm going to hit second and calculate. We want number 5. So that's the first curve. Yep, that's that line. And then I hit enter. This is the second curve. And then we hit enter and it says, do you want to take a guess? Well, if we guessed, it'll take a while to hit the cursor over there. So one thing that we can do is we can just hit, I think we're about at, like, say 2. So we'll hit enter. That's our guess, and it actually finds the intersection point of -1.619 and -559. So we're going to round this. We're going to say 1.62. So the intersection point is going to be, change colors here again. The intersection point is going to be 1.62, comma, and then this is going to be 0.55. Well, it's either 5.5 or 5.6 based on this one right here, so that's going to bump that up to a 5.6. So -0.56. And then we'd circle that, and that right there is the answer. That is our intersection point, which looks pretty reasonable on that one there. So let's take a look at the next one. Let's go ahead and enter this in. So I'm going to clear both of these off. And then we're going to come back here and we're going to do 1/2. So I'll do parentheses, 1 divided by 2. And then we'll raise that to the x. Hop down on the next one. This is negative, and we're doing parentheses, 2 parentheses, whoops. And then we're going to raise that to the x. And then we're going to hop down here, and it's +2. Okay. So this is a base with an exponent, so that's an exponential, and this is a base with an exponent, that's an exponential. So this will be interesting. Let's see what happens here with these shapes. So we've got, let's see, we'll go ahead and hit graph, and it doesn't have a scale, and this looks a little bit crazy. So what I'm going to do is I'm going to hit zoom 6 and see if we can get a picture of what goes on. Okay, so this one comes down and goes like that, and this one comes over here and then it goes down. So I'm going to zoom in on this one. I'm going to hit zoom, and if you hit number 2, we haven't done this before, zoom in. Okay, it's got the cursor right there, and we're going to hit enter, and here's what happens. All right, now that's a really, really a pretty good picture here. so we can kind of tell what goes on. So let's go ahead and hit the window. So this is negative 2.5 to 2.5 in each direction. Okay, so we'll go 1 and 2 and 1 and 2 and 1 and 2 and 1 and 2. And then if we take a look here, so let's go ahead and go back to graph here. So I'm going to hit trace. We're on the first one. It looks like that one crosses right here. So it hits at 2. And then as we go out here, let's see where we are at, at 2. So we hop over there, we're at 0.25. So we're barely above the x-axis right here. And then at negative 1, we'll see what we get there. We're at 2. Okay, so we're right here. So this is the shape of that graph. It does this. Runs along here, goes like that. Okay. Now the other one, let's see what type of values we have here. Let's just hop on there. Let's see if we can clean that up just a little bit. We're on trace, and let's type negative 1. So it says 1.5. So we're about right here. Okay. And then as we go further out, you'll take a look at what happens. So like at, let's say negative 2, we could hit that. 1 3/4, so about right there. And then let's check over here. Let's check what happens at 0. It hits 1. And again, notice what I'm doing here is I've just got it in trace mode, and all I'm doing is I'm hopping around to the things that I want. I want to see what happens at 1, because that's where that tick mark is. So I'm going to hit 1. It's at 0, so that's good to know right there. And so it goes like this. Runs along here, goes like that, and then it goes down. Now, we put arrows on both ends, and then I'm going to zoom out again, and let's take a look at this in the standard window. Well, that looks pretty good, zoomed in right here. So again, this is negative 2, negative 1. This is 1 and 2. Negative 1, negative 2. This is 1 and 2. Looks pretty decent there. We do need to find the solution point, so let's have this calculate it for us. So this is going to be 5. First curve, yes. Second curve, yes. We're going to guess. Well, it happens to be right there. It happens to cross right at 0, 1. Now, we get lucky on this one. It's a nice point. We could kind of see that on the graph. So that's kind of cool. There are times where it will look like they cross and maybe they don't, or they don't on a particular interval. On this one, we get kind of lucky. Let's come down here and let's take a look at C and see what we've got in store there. Again, on that second page, there's that information about how to graph those. So I'm going to come back here, clear this one off, clear that one off, and this one's going to be 2 raised to the x. And then we're going to come down here, and in order to graph this, we need to move this to the other side. So this is going to be negative y equals x, and then minus 20. Yep, that's the only one that would change. And then we're going to divide everything by a negative. So this is going to give us y equals negative x plus 20. So we're going to graph this one, and we're going to graph this one. So that's going to be negative x plus 20. Okay, so we'll go ahead and hit zoom 6. We'll graph that in the standard window. So we've got that exponential kind of like we were looking for. And it looks like this is... Looks like that's done. So I'm going to hit trace. We're on that one, and we can kind of go along there. And then this other one, well, remember, this would cross at 20 and it would have a negative slope. So if I hit the up arrow and got on that one, that means we're at 1.418. We're way off the graph here. So let's go ahead and change this just a little bit. Let's go at least up to 20. So we're going to hit the window. And negative 10 to 10 is fine there, but let's go from negative 10 up to, let's say up to 30, and then let's graph that. Okay, there we go. So that's not too bad. We can tell that we've got our exponential right here, and then we've got the linear one right here, and then we're going to see where they cross. So we're going to hit 5, first curve, yes, second curve, yes. Guess if you want to, go over there and see how close you can get. We're going to hit enter, and they cross at 4, 16. So it just so happens that those cross at a really nice function value, 4, 16. Okay, so that's kind of an idea of how you can use the calculator to graph those and see where they cross. Should be in good shape there.